Good afternoon, everybody. It's quite unusual for me to be giving the non-technical talk in a short afternoon session, but that's what I'll be doing this afternoon. So, as John says, I'm Chief Scientific Officer for the GEIC. I'm a professor in the Department of Materials. And I want to talk a bit really about how GEIC sits in the broader context of the university and the opportunities that brings to the companies that we work with. So, you've made it to this building. But this building actually was built on an idea, and the idea really was to develop a focused activity beyond the fundamental work that was happening in the university departments and the National Graphene Institute, so that we had this industry-led development at the higher TRLs in graphene and the broader family of 2D materials. And that this should happen in collaboration with academics, with the academic community. So we're all familiar with TRLs, but I put the graphic on there because actually I'm never keen on silos, and we're actually in a little bit of an overlapping space here. So in the university, most of the time in the departments, the academics and their research groups are working on very, very fundamental work. They're working at these lower TRLs, 1, 2, and 3, and looking to develop the knowledge that can take us towards product, but they're never really getting to that scale-up space. GEIC works in that space where we've got something which has been demonstrated in the lab, and we're looking to move that forward. That's a space that a lot of academics have got. Many academics have a lot of exposure, but a lot of academics also have none whatsoever. So what we're trying to do is build a model where we can bring everybody together in that space. And John and I have talked about this before. I left that we work at TRL 4+ in the GEIC. We do dip down into the lower TRLs in this space, but we certainly don't go to TRL 1 in the GEIC. And most of the academics in the university aren't moving up to TRL 7 and getting anywhere near the development of a system. So, our university, as you'll be aware, we're celebrating our 20th anniversary of the first paper in graphene, and we're also celebrating the 200th anniversary of the university this year. GEIC is very much part of the university, and the university, of course, the first civic university, was developed on the back of, or was born out of, industrial need. Very Manchester story. It was developed around a pub table, and they decided that this was exactly what was needed. Was somewhere to educate and to do research to support the burgeoning industries of the university, of the city. The main interface that GEIC has is with our Faculty of Science and Engineering. That contains 700 academics, 400 postdocs, and about 1,700 PhD students. They are not all working on graphene, but actually that's part of the story that I want to be telling in these few slides. So this very large resource. We also have two other faculties, which we do touch on, one of biology, medicine and health, and one of humanities, which the humanities faculty contains our business school as well. So you can see there are natural interfaces. So we are in two schools in our faculty. And the first school is the School of Natural Sciences, and that's those departments: chemistry, earth and environmental science, materials, mathematics, and physics and astronomy. And we also have a School of Engineering, which is going through a little bit of a tweak of the names of its departments, but currently they are computer science, chem-eng, electrical and electronic, and mechanical, aerospace, and civil. So we're covering the whole breadth of the science and engineering space. What we have is, of course, inevitably, people are working a lot of fundamental work in these spaces. And we have a team in the GEIC who are working very much in the applied space. So what we want is to be able to ensure that we've got that connectivity across the TRLs, and I'm going to talk about that now. So, bunch of faces. Two of them are in this room. I'm going to get them to wave because you might not recognise them from their school photos. Mark Bissett here, bigger Mark, come on. Thank you, Mark, and Steve Edmondson here. So this is a team who work for me in ensuring that we can connect our projects and the work we do with industry with the broader university. And we do this for mutual benefit, and that's what I want to lay out to you over the next couple of slides. So inevitably, with that very large number of people that I've just laid out in all of those departments, we need to be able to go out and and help companies and help the team in the GEIC to connect with the work that's going on in those departments. The GEIC came out of the work that was going on in the departments that was expressed through the National Graphene Institute. But that's just one source and one part of the reservoir of work that we can exploit to take to product and to commercial exploitation. So when a company comes to us, and I'll talk a bit more about how we do this team work with the application managers, who you'll be seeing a bit more of after this, and who you'll met over the last couple of days. They work with them to help identify where, firstly, if there is a need for support for the GEIC team, and secondly, where that is in the university. This means not just the academic expertise of people, but it also includes the equipment of the broader university. Many of you would have spent yesterday with us in the NGI and would have walked down past, well, the NGI is right next to the Henry Royce Institute, and you'll have walked past the Manchester Engineering Campus Development, MECD as we call it. In those buildings, we have 700 million investment in capital and equipment. This building has an enormous amount of equipment in it, but it's a fraction of what's available in the whole space. So what we're able to do through this team is make sure that if we don't have it in the GEIC, we're a one-stop shop that the projects can access that broader facility of the university. And it's not just the equipment, but it's the people who've either commissioned the equipment, built it, looked to inform it, and also done projects on it. So this team who work with me, they come from the Department of Materials and Department of Physics and Astronomy. They all have experience of working with industry. Manchester academics, particularly in materials, do a lot of work with industry. But part of their job is to help reach the academics who maybe have not worked with industry so much. That can be tricky sometimes. Sometimes industry finds it very difficult to interface with academics. Sometimes academics find it difficult to interface with industry. What we're trying to do is soften that, make it easier for people to have conversations, make the energy barriers a bit lower, and help people reach the right people and help the conversations take place in a sensible way. So the typical starting point for an academic engagement with a GEIC project is that there's been conversation happening between a company and someone in the GEIC, one of our applications managers typically, or one of Ivan and his team. And the academic gets involved, having been identified by my team of theme leads, to provide a bit of expert oversight to the activity. That oversight is typically not in graphene. Of those very large numbers of people doing research, then we know that we've got the graphene expertise in this building. We've got a bunch of people who really understand this material and it's handling really, really well. But you've just been hearing through the last few talks about the potential to be working in cement, in paints, in batteries, in other materials systems, or other systems that are dependent on materials. And we have experts in all of those areas in the departments of the university. So the team there can call on those people and run things past them, essentially, to say, we've got this, we're working with this company, we've come up with this idea, and the academics say, yeah, you can take that a bit further. Or maybe say, actually, we don't need to do that piece of work. We know all the answers to that. And so we can move more quickly and get to where we want to be more rapidly. So they're there to engage with the GEIC team during the project. Research, translational research, all research, but translational research as well, is not necessarily linear. We do experiments and we get unexpected results. And of course, everyone working in the academic community knows that collaboration really, really helps. People who work on their own tend to get stuck. So having this team available, having that extended team available, means that we're able to unravel and solve problems more rapidly and bring some fresh eyes to something. The team look at the report and talk through that with the team in here to see if there's any opportunity to draw further results or for further conclusions. And of course, they participate in the review and the closeout meetings with the company. So what we're doing is we're helping the companies to build the relationships with the academics as well as with the team in the GEIC, and we're helping the academics to build relationships with the companies. All of this stuff, no matter how much we're talking about science and equipment, depends on the people that are involved in delivering it. So, the model. The model we're looking at typically starts up in the top central blue box there, that we have an industrial project in the GEIC where a company looks to do something with us that is going to help them lead to product or application incorporating graphene or possibly another 2D material. And we've got some green there. So the green is the academic input that comes into that space in the way that I just described. The purpose of this model is that things don't stop there. Of course, GEIC exists to help with this translation. We exist to help people to develop product and move through. But those of us who've worked a lot with industry over a lot of years know that these processes lead to new questions. And often the new questions are deeply fundamental. And that's not the work that we do in the GEIC. So what we look to do with those new fundamental research questions is either develop projects with companies to do in the departments of the university, so we're moving over with those blue lines over to the left, to what might be a PhD project or a postdoc, which could be fully industrially funded. Or we can work where the academic starts to get ideas and say, well, I could put in a grant to the EPSRC in this space. And that grant may be more successful if it's got the company writing a letter of support for it. This is really important. This isn't just for academics. This is quite an easy sell to academics, but this is really important for industry too. It means that if you're helping us to obtain funding from the research councils, then we're helping to do the fundamental work that will lead to translation a number of years down the line. This is the stuff where you need to be looking at things that take 5 years or 10 years. And we've got to feed from what's happening in the GEIC in this short-term, very rapid turnaround projects to feed the work in the lower TRLs in the rest of the university that will come back into the loop for translation further down the line. So that we're not just exploiting what was done in that early work in the NGI or in the physics department, the NGI and the Department of Materials and Chemistry overwhelmingly 15 plus years ago, but we're making sure that the work we do now has industrial relevance and gives us the new questions to solve the problems that are going to come at us down the line, further down the piece. In the bottom right, we have a small subtlety. Work carried out in the GEIC has to be 100% funded by industry, which means that my theme lead team will work with academics and companies to build packages which we can deliver in the GEIC. Of course, if a company is going to fund a PhD directly, and many do, then we can do that in the GEIC. But there are schemes I've just put above the UKRI box at the bottom, like the Impact Acceleration scheme and the Knowledge Transfer Partnerships. If you try and build one of those off the shelf without talking to the GEIC, the chances are that this rule will come in and we won't be able to do it in the GEIC. But if you work with the academic theme leads, you work with me and my team, we're very confident that we can build packages where that work can be done in the GEIC and we can get some support from government for those kind of activities to be done in this space as well. So, to close, GEIC is very much an integrated part of the university. We're a very big organisation. We're the biggest employer in Greater Manchester. This university with 11,000 staff and 40,000 students is the size of a small town. So there are many, many front doors. We hope that once you get through one of them, the GEIC being one, there's some connectivity behind it, and that's what we're looking to achieve in this space. So through your interactions with the GEIC, you do have access to the broader university activity. The academic support that we bring to GEIC projects keeps the teams in the university and our teams and our industrial partners mutually aware of developments in the field and the opportunities and drivers for translational work. It's a two-way piece. As I've mentioned, we can't do everything within the GEIC, but there's a whole lot of stuff we can do outside, and we do a one-stop shop with that. So there are examples where we've done projects with companies where we've utilised our phenomenal facilities for X-ray computed tomography in the Royce facility. We don't need those things in the GEIC. We've got very good equipment for characterisation in the GEIC, but we can take that further with the high-end microscopes that we have in the rest of the university. So all of these facilities are available. And finally, and the most important piece is, do discuss your needs with us. The GEIC team can facilitate these conversations. We can make really nice packages to help you navigate this very, very diverse and complicated organisation and navigate that space and I've lost that, never mind, navigate that space and get to sensible outcomes for all partners. So I'll close that there.